Hello everybody, my name is Peter and welcome back to my channel. So today I'm bringing you a tutorial on how to make this 3D sprite effect in Unity, where we have 3D sprites that actually interact with the 3D environment by casting shadows and automatically sorting based on their position. I'm doing this video as a follow-up to my 5 devs versus 1 game video that came out a little time ago, since this is the main effect that I used for my game for that jam. The sprite sheet that I'll be using comes from opengameart.org, but you can of course use your own. Just make sure that every animation frame on the sprite sheet is the same size as the others. With that out of the way, let's get right into it. The first step we need to take is to make sure that the alpha is transparency checkbox in our sprite sheet's import settings is set to true. Then we also want to assure that the wrap mode is set to repeat, the filtering is set to point, so we can have sharp edges, and optionally that the compression is set to none. Now, let's simply create a new 3D object plane in the hierarchy onto which we're gonna test our material. Back to the project window, right click and create a new shader PBR graph, and let's rename our shader to something like 3D sprite graph, or you choose it. Now right click on the shader to create a new material which is already linked to it, rename it properly and drag it onto the plane to apply it. Now double click the shadergraph asset and the shadergraph window will pop open in the editor. First thing first, let's set the shader properties in the blackboard. We're gonna need a texture 2D that I'm calling main texture, which I'm giving the sprite sheet as a default value to, and a vector 2 that is gonna represent how many frames are there on the sprite sheet on both the horizontal and vertical axis. Since I'm using a square with 16 frames, I'm setting 4 and 4 as the values. It's not mandatory to give custom reference names to these properties, but it's good practice to do so. So I'm setting them as underscore main text and underscore grid respectively. Now, let's create two vector1 properties which we'll call current column and current row, set their mode to integer and the reference to underscore curcol and underscore currow. For these last two properties, it's fundamental that you note down the reference names, since we are gonna use them later to animate the sprite. Now let's get started. Drag the main texture in the editor and connect it to a sample 2D node. Drag the RGBA part to the PBR master's albedo part and the alpha to the master's alpha. Since this is an opaque shader, we are not gonna handle semi-transparent pixels, but instead set the alpha cutoff value to something like 0.5 to cut off all the transparent pixels. Already you can see that the shadows and transparency are being rendered correctly. Now right click and create a new UV node and connect it to the A part of the divide node. Then drag the grid size property in the editor and connect it first to a truncate node to make sure that the values always have a decimal part equal to 0, and then to the B port of the divide node. Now let's add the new divide node and connect the truncate node of the grid property to the B port of this one too. Drag the current column and current row properties in the editor and plug them into the X and Y ports of a vector 2D node, then connect it to the A port of the last divide node we've created. All that needs to be done now is to add the two values together and connect them to the UV port of the sample texture 2D node. We can already see that things seem to be working, so let's go over what we've done once again. We have basically divided the initial image in a grid of grid X times grid Y cells. Then we're using the current column and row like they were the indices to a 2D array and selecting which frame to display. You will notice that if you go to the material properties in the inspector, you will now be able to manually select which frame to display. Let's now create a new script and attach it to the plane. Then open it in our text editor of choice and let's start coding. We'll begin by creating a new public enum inside of the class that we're gonna use in a minute. I'm calling it animation axis and giving it two possible values equal to rows and columns. Then let's get a reference to the mesh renderer of the plane, and let's also declare two string fields which will store the names of the shared properties for the current cell we want to select. Now, let's create an animation axis variable, which we'll use to determine whether the animations are oriented vertically or horizontally in the sprite sheet. We're also gonna need a float value to configure the speed of the animation and an integer to decide which animation to play. This will allow us to select a row if the animations are oriented on the horizontal axis or the column if they are vertical. In the update method, let's check what the value of our animation axis is. If it's rows, let's set the local clip key string variable to the current row property name and another local string variable called frame key to the current column property name. If the axis is columns, let's just simply invert the two assignments. Now, to have the animation loop, we are multiplying time.time by the animation speed and casting it as an integer. This will allow us to select one frame at a time. The last thing we need to do is set two floats in the mesh renderers material. First, let's set the vector one with the name stored in clip key to our animation index, and then the one with the name stored in frame key to the frame we've just calculated. After assigning the planes renderer to the script and hitting play mode in Unity, you notice that things look weird. That's because we need to properly set up the animation axis. Now things are looking way better and we can play around with the speed to achieve an optimal result. From this point forward, you're on your own. Deciding what animation to play and how to play it heavily depends on the game you're making, so I can't really guide you over there. In my level for the 5 steps from home jam, I was working with a sprite sheet very similar to the one I showed you so far. When the character is walking, I simply select the clip that's facing the correct direction and loop across all the frames, while I'll only display the first one when it's sliding. This way, you can also see how we can extract 8 different animation states from just 4 frame loops. And that's it. I've been a bit under the weather today, so that's why the video was less energetic than usual, but I really do hope you've enjoyed it and that you learned something today. If you did, please show your support by subscribing to the channel, leaving a like and or commenting with thoughts, feedbacks or any ideas that come to your mind. This said, I've been Peter, you've been amazing, and in case you decide to stick around, see you next time.